Hello future tech leaders, I am Sindhuja. Based on my own experience, I know that learning the right skills can shape our future. What if I say learning was as thrilled as the tech world itself? There we go. A cloud foundation, that's exactly what you will experience. From day one, you will be immersed in the interactive sessions and expert-led courses that covers most of the widely used technologies in the zone of data science to cloud computing, which brings more light to the life of a techie. I'm so excited to help you and unlock the true potential of a technology. Well, then why to wait? Let's see what it unfolds.
Now today my part is I would like to discuss about internal messaging of the Mule applications. Using VM component, we do internal messaging between Mule applications. It is called a virtual machine component. It stands for, but in simple terms, it is called it is a messaging system between Mule applications. It is a virtual machine component. It is a virtual machine. 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 So usually it is a JMS queue that is called ActiveMQ or RabbitMQ. Some implementations are there in the JMS queue. It is ActiveMQ and I can share the RabbitMQ also. How to use RabbitMQ? That is an implementation JMS we can use in between multiple. Different kinds of applications, heterogeneous applications, like maybe one application is running on a Python or Java or any other technology. So this application want to send a message to Mule application. So it will send a message to the JMS queue and Mule application can listen that message from the JMS queue. Mule application can able to listen that message from JMS queue and process that message. So JMS is for multiple kinds of applications. Even we can put JMS between Mule applications also. It is not there, but JMS, we can use different kinds of applications. Can you know? JMS work as a broker between different kinds of applications, where the VM component is purely between Mule applications only. VM is purely between Mule applications. And other thing is Mule applications run in a runtime server or runtime. Suppose this is Mule runtime, where we deploy all the Mule applications inside this runtime. This is Mule application. One Mule runtime with a server. Mule runtime with server where we deploy Mule applications. Even if we are executing the Mule applications in any point, Studio write. Any point Studio is embedded with the Mule runtime Mule server. Any point Studio is embedded with the runtime. So that we can deploy our Mule applications. That runtime is called embedded runtime. Embedded runtime at any point studio. So embedded runtime is only for testing the applications. It is not for production grade server. Whatever application you develop in any point studio, that application you test inside this runtime. But Mule provides you the runtime on prem runtime. You can download it and you can deploy. You can deploy applications on that runtime. You are going for production, then you take license. But for learning purpose, you can download the server and you can use it. So where we are? We are actually between COOS and JVM. COOS JVM component is the communication channel between the Mule applications that is running on the same runtime. So in this runtime, two applications got deployed and I want to establish a communication between this app1 and app2 to VM component. App1 can send a message to the VM and app2 can take out that message from the VM. So VM components are the broker between app1 and app2. VM is one of the components. Is not a Mule runtime. Mule runtime is a place where we deploy Mule application server. Actually, this entire Mule is a Java application. Now, first of all, very first thing, why we need messaging is there. Any application is there, app1. And when app1 wants to send a message to app2, it can send directly a message to app2, right? Then why we need to put a broker in between? You want your application to be more reliable. We are not sure our application will be running all the time. Maybe application is down for some time for some reasons. For example, app2 is down. It is not responding, so app1 keeps on sending messages to app2. Not aware of it is running right, so we will lose the messages. Instead of that, if app1 will send messages to some queue, messages will be stored inside the queue. Whenever app2 is up, it will take the message and process the messages. In Mule, if you want to put this kind of queue between two Mule applications and app2 running inside the runtime where the Mule applications are running, that is called a VM. There is one thing to publish a message. To publish a message from application to VM, there is one component that publishes a message. To receive a message from VM, there is one component that is VM listener is there. We will discuss about VM components. What are the different components available? Now we are discussing about the concept called message channel. What is the difference between the VM component and the JMS component? Both are look same. Both functionality, the purpose is same. It looks a little confusing between the VM component and JMS component. That you need to understand the difference between where we need to use VM and where we need to use JMS. So JMS, go of JMS. JMS is a different server. For example, if you take RabbitMQ, we need to download the RabbitMQ and we need to start the RabbitMQ server. So inside RabbitMQ server, we need to create queues. Every queue has a name, but suppose you create a queue called Q1. And what we do is, there is some application is running on NetT. So this guy will send a message to the Q1. And our application can listen that message. And pass that message. You will be sending on. This application is running on the runtime. Okay. So RabbitIQ server is not part of the new runtime. That's right. Right, this new server is different. This new application is running. And NetT application is running on some NIT server, some ISS server or something. NIT server. A separate server. So a client has a separate server. A Mule application has a separate server. RabbitMQ has a separate server. So this may be sitting on a different machine or maybe a different geographical location. And our Mule application is sitting on a different location. Maybe geographically they are apart. Right. So if you have such a requirement, then we go for JMS. We are establishing communication between different platforms. This is a neat platform. It is a Mule platform. Different technologies, wow. They can talk to each other using the JMS. Metagenesis technologies, whereas come from Mule. Sorry, VM component. VM component. Actually, there is something called JVM. Java extension. Where all Java applications are running. Mule runtime is also one of the Java applications. So Mule's runtime or Mule server runs inside the JVM. And inside the Mule applications we deploy. Sorry Mule server, we deploy Mule applications. This is M1, M2. Mule application 1 and Mule application 2. Mule server hosts the Mule applications. Java which hosts the Mule server. And maybe some VM component also as part of the Java virtual machine. Right. Mule application will send a message to the single component. And M2, the server Mule application 2 can take a message from the VM component. So this is local to the Java virtual machine. So this is little fast compared to JMS. VM is fast because it's local, right? It's not crossing the boundaries of your machine. Everything is running on the same machine. Look, M is fast. When your requirement is very simply, you need to establish communication between the Mule to Mule or inside the flow to flow. We go for the Mule. Okay, that improves performance of the application. Right? When two Mule applications are running, one Mule application is running on one Mule server. Another Mule application is running on other Mule server, a different Mule server. Mule application are running different Mule server. Then if you want to establish a communication between these two applications, then we need to go for the JMSS kind of server. JMS, because they are not running on the same application, right? Same server. So where we need to go for VM1. If they are running on the same server, the application is running on the same server. We go for the VM. The applications running on different machines. We go for the JMS. There is one exception. I can tell you that one. When we deploy the application to the cloud, I will tell you that one. As of now, just focus on this one. I can tell you the VA. Once we discuss this one at deployment, I will tell you that one. How it behaves on the cloud. JMS is actually a spec. Spec means it talks about how do you know how a Java application talk to the machine system. To messaging server. This is the only spec where there is no implementation defined in this spec. Only a specification. Just it talks about how your Java applications can send a message, can consume a message, can listen to a message. All the things are defined. Only simple rules and regulations are defined. There is no implementation. So the companies like RabbitQ take this spec and develop the messaging server based on the JMS server. Now, this is the actual implementation part. People can put a message over here, can listen to a message over there. And companies like RabbitQ, so many companies have their Appium queue. This is also based on JMS spec only. Take the JMS spec and develop the server. J. So different servers are there, all based on the JMS only. But these are actual runtimes, actual servers where they host the messages. They are all based on JMS only. You take the JMS spec and develop the server. JVSMQ can develop this standard. JVQ is a standard. JVSMQ is a simple standard which is not an implementation. Where is the Appium queue? JVSMQ. These are all based on the JVSMQ. They are developed based on the JVSMQ. With the help of JVSMQ, we can send a message to these servers. These servers may be running different port numbers. If you configure that one, it will go to that server. VM is not a full-fledged messaging system. It provides very simple messaging. Just put a simple message to push a message to this queue and consumption of messages. Simple, something like that, but you can't get acknowledgement, all that stuff. VM is a very simple messaging system. It doesn't have advanced messaging features. And if your application needs advanced messaging features, you need to go for JVM. Sorry. So let me create one simple application. See runtime. For the runtime, we use server Photon. Embedded insights in the Point Studio. That's right. My project is simple. So what I'm doing is I'm just publishing a message to the VM queue. So I'm configuring a listener. So HTTP client, I just get a message from HTTP client, and whatever message I got from the HTTP client, I will push that message to the VM. So I'm configuring the HTTP message. Is okay. The default configuration is fine. Path has been given, we can send something. You search for VM on the component palette. You find 4 components: consume component, listen component, publish component, and publish consume component. Right. So to publish a message, we use the publish component. So if I put a publish component over here, what this component will do is it publishes a message to the VM queue. So I'm configuring the publish component over here. Connector configuration. It tells about how Mule application is connecting to the VM queue. You need to give the queue names. What I'm doing is, I'm just creating a queue name. And I need to tell the queue name to which queue we need to post the message. I'm just creating a queue name. I'm giving it as something in the name. I can give VM1. And here, the transient tells about transient. By default, it is transient. For example, when the server is when this application is executing. Some reason the server crashes or we lose that message. Oh, it's the same configuration. If you put this queue as persistent, what happens is it stores the message to some external storage like a file system. So even the server crashes, we can the messages, call messages will be remained in the file system. We can restore the messages. That's the configuration of transient and persistent. So we can tell how many messages to host. That is about a max of sending messages. 0 means it can host a number of messages. There is no limit for that. So that is another queue configuration. Queue name is VM1. So now, this is the only connector configuration. We just created a VM queue over here. Alright. And next thing is what content we're going to post to the VM queue. So now I'm posting the payload. Or else, if you want to post some variables, you need to change them to the variable name. So that variable content will post to the queue. This correlation ID. We will discuss what is the important part of correlation, how the messages got correlated. I will tell you this one first. We go for simple thing. We will just go for complicated thing. Next thing is a queue name to which queue you want to publish. Right. So I want to publish to the queue called VM1. That is what I created in the connector configuration. Queue name is VM1. So in the connector configuration, you can create multiple queues. For example, I'm creating one more queue as a VM2. Yeah, I'm making this as a persistent configuration. So there are 2 queues I created, right? One is VM1 and VM2. While sending the message, we need to tell out of VM1 and VM2. Which queue we want to send. You can choose either VM1 or VM2. I want to send to VM1. Now what happens? To publish like this. This publish component publish the message to the VM queue. That's it. It is a one way only. Okay, so it won't expect any response from the VM server. If you put logger after this, what happens? I'm just publishing the building of payload. Payload of the. I'm getting the payload. Let's observe. I'm trying the application. So meanwhile, I can tell you one thing. Here you can see the 3 tabs write message flow. Global elements and configuration XML. 3 tabs right. Message flow section. This is the graphical view of your new application. So graphically, you see that this is not published component and logger. And if you see the configuration XML, this is a source code view. The same application. If you do anything over here, add a new component or delete a new component, that's what you will get over here. Okay. So now, as part of your Mule, a configuration Mule applications. There are some configurations we use in multiple flows. This is one flow, right? You may have one. This Excel can have multiple flows. This is flow 1. And you can drag one more flow. This is flow 2, right? Flow 1 and flow 2, you have multiple flows. If your configuration used in multiple flows, the same configuration, what we can do is we can make it as a global configuration. And that global configuration is referred in multiple flows. What I'm doing is here, I'm creating one more flow. I'm referring this one. That is part of C, only part I changed. See, if you see, this is called VM send and this is VM receive. And counter configuration, see the counter configuration is HTTP, lizard config. And here also the counter configuration is HTTP, lizard config. They're both referring to the same counter configuration. Right. I'm putting some logger over here, simply one logger, and these both flows are referring to the same configuration, same lizard configuration. Right. So that is a global element. See, global HTTP lizard config is a global element. And that global element are referred in multiple flows. In sense to one thing. Come to configuration XML. Right. See here. In the configuration XML, there is a tab called flow. It's a flow starting. And this is called flow ending / flow ending. This segment, right? This segment represents a flow. This is one flow and there is one more flow starts with. The 2 flows are there inside. Okay. So if you see, this is flow 1, this is flow 2, right? The same thing. So the configuration inside the flow starting and flow ending, that is called flow local configuration. So this is called flow local. Inside the flow, simple flow, right? This is also local to this flow. But if the configuration is above all the flows and it is not inside a flow, see, this is not inside, not enclosed in any flow. And this configuration is also not enclosed in any flow. These two configurations are called global configurations. Okay, they're not local to any flow, right? And there is some component called HTTP listener. It's referring configuration ref, referring to something called HTTP listener config, right? This HTTP listener config is defined over here. HTTP listener config. So what this listener component is doing, it is referring the global configuration. See, the name matches over there. Ref and the name should match. These two are matching means this is referring this global configuration. What is the global configuration? The host is a local host and port is 8881. And the second flow also. The second flow also the HTTP listener attack. That is also referring to HTTP global configuration, HTTP listener configuration, this one. Right. Means both flows. Both the listeners are pointing to the same host and same port. And what is the difference? Is this is defined second a path called VM, receive the second listener. This is VM send. Okay, this should be different. If you don't, if it is also the same, you'll get error. See, this is also global configuration. VM config is global configuration. It's not enclosed in any queue, any flow. This configuration is referred while publishing the message. Right, see? VM publish is a component that publishing the message to the queue VM :publish. And there I can expand this one. VM publish queue, name is VM1, this publishing VM1 queue. And reference here. Host stack format. Yeah, VM publish. Configuration is VM config. So where the VM config is defined, that is different as a global configuration. Even the second flow, what I can do is I can consume the message. In the first flow, I publish the message right. In the second flow, what I do in the second flow is I consume the message. For that, I am going to the VM. Consume the message. But consume the message, also I can refer to the same VM configuration. Publishing. Also I am configuring the same VM config. Consume the same VM config. I want to listen from a queue called VM. I publish to the VM1 queue. I publish to VM1 queue, consuming from the VM1 queue. Right. What is the basic difference between synchronous and asynchronous? Any kind of an application I make a client. I send a request to this application. The same request, the same thread. I expect the response. So maybe I wait for 30 seconds or something like that and the same request. Request is sent and I will expect the response. If I don't get the response, the client will timeout. Timeout error. Yeah. So this is called synchronous call. Oh, right. So the client expects the response immediately on the same call. It won't wait for a long time. Whereas asynchronous work like this asynchronous. Client. Send them this request. And what is asynchronous? Where we do for asynchronous, there is on this request. It requires some approvals. For example, you are applying for a loan. And loan. They won't approve you at that moment. They do some background checks and some credit checks. And after that, they will respond back to, okay, your loan is sanctioned, something like that. Okay. So for that, for long running process, we use the async system. For async system, what the client will do is along with the request, he will send the callback URL. Call URL. Yeah, along with the request. He will send callback URL and tell that server, hey server, once you complete your process, send your response to the callback port. And it will send the response to the callback port. Then the client will pick up that response to callback port. That is not happening in the single call. One call is for request. And the server get the callback URL. After processing, the response will send to the callback URL. Okay, now these are two different calls. One call is for request and one call is response. This is asynchronous call. It's on timeout, asynchronous. It won't expect the response immediately also. So it won't wait for response from the server. Just send the message, that's it. One way only one way. It is one way. And this is one way. One way response, one way request and one way response. Whereas it is two way. Synchronous is always two way. Two way means request and response on one call. Request response messaging pattern. These are all called messaging patterns. In a synchronous call, it won't wait for response. There are two types of asynchronous calls out there. One thing is as a client. I'm calling the server application. So I'm just sending a request. I won't wait for response. And just send a request. And I can do other activities also after this one. For example, there is something called send a request to some queue. And next print that request to the file. And do some database call. Something like this is there. So what I can do? I can send a message to the system and continue my work with other components. I don't wait for the response. I want to block over here. Whereas in asynchronous call, I block over here. Until I get the response from the server, I can't move forward. Once I get response, only I can move forward. That is called synchronous system. Synchronous means it blocks. It blocks until you get the response from the server. It blocks here itself. Whereas asynchronous, it just sends a message to that server and keep moving and executing. Next components. Now sometimes we get doubt, we send a request. How we can get the response back and where we can collect that response. So, like I said, there are two ways to collect the response. One way is no, it is not related to Mule. It's a general concept actually. Assume this is the client. This is server. The client sends a message. The client also expecting a message but not immediately. It knows this is a long duration call. Server will take some time. After some time, the client will expect the response of this message, the request of response of the request. There are two ways we can do asynchronous call. One is polling manner, polling way. Polling way is something like there is some agreement between client and server. So once the server processing this request, it will put in one place. Server take the request and process the request. After processing, it will put the response in a place. So the client keep on checking this place. Is the response arrival? Is the response arrival? Is the response arrival? Some scheduler call it. Scheduler keep on checking this place but need response. If the response is available, we fix that response and process that. This is called polling manner, polling way. And second is the callback. In callback way, client won't poll, won't check for response. While sending the request itself, it gives some path. Hey server, once you finish your processing, please send the response back to this path. The path is given in the request itself. So server process that request, and once you finish the processing, the response is sent back to the path the client has given. The client pick the response. So these two are the asynchronous ways of implementing the system. Okay, this is a bit preferable manner compared to polling. A callback is preferable because client need not check every time, right? Once you are processing, you get the response from the callback port. Okay. But see, this is one way and client also server sending to client in different calls. This is two-way call, right? Two different calls. Yeah, not in single call. Single call means single call that is synchronous. What's the important, takeaway in the today's session is about the source code. Most of time we work on the graphical mode. Yeah. It is equally important to have idea on the source code, how the source code is getting generated. You add a new component or you delete a new component. What is a global configuration? What is a local configuration? That idea is very important. I'm running this application. I demonstrate and compute. Oh. There is some 8 or 81 complete in my machine. So I change it to 885. /VM. I'm sending some content. This is the content I'm sending. This message I'm sending to the VM. Post it. And yeah, we send that message to the VM. And next, I want to get that message from the VM. This will be. And what is the path to get that? It is a flow that is fetching the message from the VM, right? Yes. Get. I'm spilling this. I push to the VM and other from the VM. Okay. So this is the. What I did is from the postman. This is called VM send write. It's a send it. Send and post to the message. Publish. Somewhere VM is there. What VM? The true name is VM1. So this will publish the message to the VM1. And it only one way, just put the message and expand and exclude the logger. Okay, logger, I'm printing the payload, whatever a post message I printed. I posted that, but it's already in the logger. I can show you the logger also. Right. And message is there in the VM log. So from the postman, again, I'm invoking this listener using VM receive. That's VM receive. That control comes to this listener. So this will go to consume. It calls the consume component. Consume will go and fix this listener, this message. And use that message back to listener, and listener will go back and send to postman. And that message got printed over in the postman console. And finally, do not forget to like, share and subscribe to our channel.